Hey, welcome to Draft Academy. My name is Mike. In this tutorial, I'm going to show you guys how to convert an ER diagram into a database schema. So basically, we're going to take all of this information inside this ER diagram, which we created in the last tutorial, and we're actually going to take this and use it to create an actual database schema. So from this diagram right here, we'll be able to, create and define actual database tables that we can use in our relational database. So let's go ahead and get started. I'm going to show you guys basically step by step how we can start converting this into database tables and database relations. So the first step, step one, is the mapping of regular entity types. So for each regular entity type, we want to create a relation, which is just a table that includes all of the simple attributes of that entity. So here we have all of our regular entities. We have branch, client, and employee. And so what we want to do is just create relations or, basically database tables for each one of those regular entities. And then the columns of those relations are going to be all of these attributes that we defined. So from everything that's inside of the green squares, we're going to get something like this. So we have our employee relation. We have the employee ID, which is the primary key, first name, last name, birth date, sex, and salary. And we have the branch with that information. Then we have the client. So I also want to show you guys when we had a composite attribute, so this name attribute over here, we're just storing the sub attribute. So we're just storing first name and last name. All right, so here we have three relations, and let's see if we can start adding to those. So step two is the mapping of weak entity types. So over here we have one weak entity type, which is inside of this green square. For each weak entity type, we want to create a relation or a table that includes all of the simple attributes of the weak entity. And the primary key for the new relation should be the partial key of the weak entity plus the primary key of its owner. In this case, the primary key of the owner is going to be branch ID because the branch is the owner. In other words, the branch is the entity that's participating in the identifying relationship with branch supplier. So over here, we'll see what happens. So you'll see we get this new table, branch supplier, and the primary key is branch ID, supplier name, and supply type. So for this table, we included the supplier's name and the branch ID. Both of those come together to make our composite key. It's a compound key. And then we have supply type, and then we end up with this. So now we have four tables: employee, branch, client, and branch supplier, and they all have their associated attributes. So step three is the mapping of binary one-to-one relationship types. Now, a binary relationship is a relationship that has two entities participating in it. For example, all of the actual relationships up here are binary. In other words, there's two parties that are participating. And what we want to do is map one-to-one relationships. So we only have a single one-to-one relationship here. It says manages a relationship. So a branch can be managed by one employee, and an employee can manage one branch. So for each one-to-one binary relationship, we want to include one side of the relationship as a foreign key and the other. And we want to favor total participation. So in this case, we want to basically include the primary key of one of these entities as a foreign key in the other entity's relation. And we always want to favor the total participation. So if a particular entity has total participation in the relationship, then you want to add the foreign key onto that entity. So in this case, branch has a total participation. So we're going to add the employee's ID as a foreign key in the branch relation. If both of them are partial participation or both of them are total participation, then you can just use your own discretion. But in this case, it's pretty clear that we're going to use branch. So over here on the branch relation, I added in a foreign key, which is just manager ID. And this is a foreign key which points to this employee's ID up here. So that's how we're going to link those two together. Step four is the mapping of binary 1 to n relationship types. So unlike a one-to-one relation, now we're looking for 1 to n. And you'll see that we have three of them here. So branch handles a client, an employee supervises or is supervised by another employee, and a branch has employees working for it. So basically what we want to do is we want to include the one side's primary key as a foreign key on the n side relation or table. So basically what this means is that, okay, so for example, in this case, we have a branch and an employee. I want to include the one side's primary key, right? In other words, I want to include the branch's primary key because that's on the one side as a foreign key on the employee relation. So basically on the employee relation now, we're going to have a branch ID column that'll store a foreign key to the branch. Same thing down here for a client and branch. So the branch over here is on the one side. And basically what that means is that we're going to store in the client table a foreign key to the branch. And then same goes for this supervisor relationship. So on the employee table, we want to store a foreign key to the supervisor. So over here, let's take a look. So employee, we have super ID and we have branch ID. And that's because the branch was on the one side of the relationship and the employee was on the end side of the relationship, which means that we're going to go ahead and store the branch's ID as a foreign key on the employee table. And then the same goes for the supervisor ID. So obviously with the supervisor ID, it's pointing to the employee table, so we have to store it on the employee table. And then down here in the client table, we stored as a foreign key the branch ID. And again, that's because the branch was on the one side of that cardinality relationship. You see, branch is on the one side and the client was on the end side. And so that's why we stored branch ID as a foreign key on the client table. All right, and then step 5 is the mapping of binary M to N relationship types. So in this case, we only have one instance of this. A client can work with an employee and an employee can work with a client. So what we want to do in this case is we want to create a new relation. So we're actually going to create a new table whose primary key is a combination of both entities' primary keys. And we're also going to include any relationship attributes. So over here, the client's primary key is client ID. The employee's primary key is employee ID. So what we're going to do is create a new table where we have a composite key, which is the employee ID and the client ID. And actually, this would be what we would call a compound key because both of its keys are actually foreign keys. And we want to store in this relationship the attribute on the relationship or any attributes on the relationship, which in this case is just sales. So down here, we created a new table or a new relation, which is works on. And you'll notice the key is employee ID and client ID. So both of these individual parts of the primary key are actually foreign keys themselves. So this is a special situation. And then over here we have total sales, which was the attribute that we stored on the relationship like that. And so basically that in essence is going to allow us to take this ER diagram and convert it into relations. Now, if you have more complex relationships, like if you have non-binary relationships, then it gets a little bit more complex when we're mapping them. In this case, I'm just kind of looking at basic ER diagrams. I don't want to get too complex. So in this case, in 5 steps, we were able to basically convert the ER diagram into a set of relations. But if you do have more advanced types of ER diagrams, then there are going to be more steps. But for our cases, there's only going to be 5 steps that we need to basically convert this into relations. And so now basically what we have here is we have our database tables, right? Each of these relations is itself a database table. So when I'm designing my database now, I know I have to have an employee table with all this stuff, a branch table with all this stuff, client table, etc. And so what we can do also, and what you'll see a lot of times, is people will draw little arrows to define the relationships. So this can get a little bit messy, which is why I kind of saved it for the end. But you can see over here for employee, on the employee's foreign keys, I'm drawing arrows to what they relate to. So for example, super ID, I have an arrow going back to employee ID. Branch ID, I have a little line here going over to branch ID. Manager ID over here, we have a line going up to employee ID, etc. So this is basically just like mapping out all the different relationships. This, like I said, it gets a little messy and it's pretty difficult to read if you have more than a couple tables. But you'll see people doing this a lot. So I just wanted to show you guys how that works. So now that we have our, essentially our relations, our database tables, we could actually create a database. So over here I have an example of what a database might look like from these relations. So we have our actual database. So up here we have all our employees, and you'll notice that we have our employee IDs, so we can define like the supervisor of each employee. So like Angela Martin's supervisor is employee number 101. So Angela Martin's supervisor is Michael Scott, right? You'll see how easy it is now for us to define all this stuff. Angela Martin also works at branch ID number 2. So that links over here to the branch. So branch 2 is Scranton, etc. And then we have our client table over here. We have our works with table. So the works with table has the employee ID and the client ID. And then we have our branch supplier table. So all of these got basically put into our database, and then we started putting information in there. And so really what this is it's a way for us to go from just a set of requirements like we saw in the last video to our actual finished database table, what you see here. And designing relational database schemas, and the schema is just like this whole thing, right? It's not super easy, right? If you have a very simple database, if you have a very simple set of data storage requirements, then obviously the schema is going to be very simple, and you might not need something like an ER diagram. But with something like this, an ER diagram is hugely useful. So here's the thing, you don't necessarily need the ER diagram, right? You don't need it, but it's a really, really great way to convert requirements into an actual database schema or a set of relations. And so that kind of shows you guys how you can do that. Now, here's the thing with ER diagrams. I only showed you guys one example, and I think this is actually a pretty good example because it covers all of the main use cases. But the only way that you're going to get good at using the ER diagrams and building them and converting them into database schemas is just by doing it a bunch. And so just by practicing. So obviously I'm not going to spend, dozens of videos doing dozens of these examples, but hopefully this example kind of shows you guys the basics, and now you can go on and design your own ER diagrams and then convert them into database schemas following those rules. And all the rules that I showed you guys for converting ER diagrams into relations, that's going to apply to any ER diagram. So what we talked about in this video will, you can basically take any ER diagram and convert it into something like this. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.